Assume this is your current process for handling invoices. You receive invoices in ServiceNow. There's some ticket, and that arrival of that ticket triggers a workflow, and it uses IDR, which is some OCR kind of process. There's a workflow that happens, extracting information from the invoice and then sending it on to Oracle Financials. The problem is there's some extraction errors in that, there's some validation errors, maybe some transmission errors, and there's a lot of human oversight needed. And that's what you're hoping to improve. Now, all of us have some kind of mental model of how such a system would work. Let me move this out of the way. There. In a traditional deterministic code-based workflow, each ticket comes in, it triggers some event, and there's probably some code or flow diagram or some combination of it in a non-AI workflow that leads to it deciding to get the invoice details from ServiceNow, extract invoice details using IDR, and then write it to Oracle. That's a traditional process. This is our mental model. There's some technical considerations. Is the code and flow correct, or are there bugs in it? Do the integrations work, or are there bugs in how that's integrated, or maybe runtime errors? And then, of course, the big question, which is how does it handle all the possible edge cases and error cases where typical non-AI workflows tend to fall over? All right. But this is actually quite different from how an AI automated process works. The desired AI automated process, and this is again what you articulated, is perhaps instead of the traditional legacy non-AI workflow, you could have an AI workflow. And the goal is using AI, it would have fewer extraction errors. It would do more validation, so there'd be fewer validation errors, maybe fewer transmission errors, and less human oversight needed. Right? So that would be the goal. Now, it turns out such an automated workflow agent is not at all like an AI chatbot that we're familiar with. So first, we should just make sure we're all aligned that a chatbot works very differently from what we want here. In a chatbot, you are in charge as a user. You provide the instructions and context. You check its results, and you're responsible for the outcomes. So the chatbot is not autonomous. Now, it's intelligent, but it does not initiate work. It tries to interpret the instructions in context intelligently. And it's also unreliable. Every time you run it, you may get different results. Now, in an AI automated workflow, on the other hand, some process owner builds and deploys it. That person provides instructions and context. That person describes the desired behavior. And that intent is specified upfront well before it runs. And the expectation is it's applied repeatedly each workflow run. So for every invoice, the same intent is applied. But at that point, AI is in charge. It initiates the work. It runs autonomously. It is responsible for the outcomes, and it only asks you as a human being if it needs intervention. So in the case of an automated workflow, the bar is higher. AI needs to be intelligent, and it has to be reliable and reliably execute the intent of the process owner. Now, this is how AI automated workflows run. And the reason for putting this slide together is because it's relatively new, most people don't have the same shared mental model of how AI automation works. But all AI automation done by anybody in the sort of modern era in the last year or two works roughly this way. And so I'll just walk through that. When an invoice arrives, let's say a ticket ID causes an event, the AI automation platform has to do the equivalent of an AI workflow, but its input is not code, it's AI instructions, which are in some natural language, let's say it's English. And using those instructions, the automation platform has to utilize a language model, an AI model, to drive the work. So it might say, here are the instructions, what do I do? The language model will come back and say, do this, and that do this will be an instruction to go get the invoice details from ServiceNow. At which point the platform calls that, it's called a tool, which would call an API to get it from ServiceNow, get back a result, which is the details. That gets passed back to the AI model. What do I do next? It says, all right, do this, go do something more to validate the details. Here are the results of that. It's passed back to the language model. What do I do next? And so on. So it's a loop. It's called an agent loop, where the platform repeatedly calls the language model. giving it updates, asking it for what to do next, executing what the language model tells it to do until the language model says, we're done. And at that point, you're done with the workflow. And this is the standard way all agentic systems work. So it's very powerful and it's flexible, but a lot can go wrong. Let's look at what can go wrong. First of all, the AI instructions might be inconsistent or incomplete. In fact, that's very often the case, that especially because instructions are in English, there are a lot of things that are left unsaid, or sometimes things that are said in inaccurate ways or contradictory ways. There can also be bad configuration, missing data, missing context that one intended to provide but didn't, or missing tools which are connections to things and function calls that can be made. So that could be two sources of errors. We all know AI models make errors. So that's the third category of errors. The fourth category of errors is there's this whole platform that's supposed to do all this work and mediate all this work, and that can have its errors. And finally, there could be errors in the tools themselves. So these are sort of the 5 broad sources of errors. And to achieve reliable outcomes, you really have to mitigate all these errors. Otherwise, it's not going to produce reliable results. Something has to mitigate those errors. In AI automation, reliability is very difficult to achieve, but it's essential. It turns out demos are really easy to build. Something that can showcase an example of this for a couple of inputs, producing roughly accurate results, easy. And then there's a lot of vendor hype about agentic automation because every software vendor claims to be able to do this. But in reality, and there's many surveys of this, only 5 to 10% of projects ever get reliable enough to go into production. In fact, it's closer to 5%. And this is not getting fundamentally better as OpenAI or Gemini or any of the model providers make their improvements. Those improvements help to some extent. If some of these errors diminish, but most of the challenges have to be addressed in the overall agentic framework, or automation framework. In fact, it turns out, depending on how you marshal these instructions and how compact you make them and construct and send to the LLM, it fundamentally alters the accuracy of the LLM itself and can fundamentally reduce the number of errors, but you have to do that right. And so there's a number of different choices and decisions and architectural approaches that the platform can make to achieve reliability. And without them, you don't have a useful platform. This is, I won't go into all the details of this slide. I will send the slides separately. But this is a way to think about how to achieve an automation platform. You can build one such AI automation using custom development, and some customers try to do that with their own software engineers. With software engineers, build it all in code, call OpenAI or Gemini through their APIs, and build all of this yourself. It is doable. You can build a demo in a few weeks. It will probably never get to production because the amount of heavy lifting needed to build the reliability mechanisms is immense. You can use a developer framework like LangGraph that provides some of the capabilities. LangGraph is the most popular of them. Some of the capabilities to actually engage effectively with the language model, to make the tool calls, to orchestrate all of this together. You still need software engineers. You're still going to be writing up your intent of your application in code with prompts. And so your developers are responsible for detecting and compensating for most of the errors. They're responsible for most of the security, etc. But some of the development work is provided by this developer framework. So this is commonly the approach in companies that have a large number of highly skilled developers who want to really build something custom. This might be an approach they take. It typically takes a year plus to build an application here that can go into production, and less than 10% of them make it. Or you can use a no-code platform like Thunk AI. There's others, but this class of applications doesn't need software engineers. It needs more process owners who can just define the process. They intend to specify it through some kind of application model in some authoring environment. And the platform, the real difference here is the platform has built in the mechanisms to detect and compensate for errors, to ensure reliability. And the platform is checking for security and compliance. The platform is executing it. The platform is deploying it. The platform is responsible for updates. So a lot of the heavy lifting is done by the platform, which allows you to really shrink the time to demo, the time to proof of concept, and the time to production in a reliable fashion. If this platform does a good enough job of all of these things. Here's what you should expect to see in an automation platform. You should expect to see an application model, some concept of what a workflow application is, and some development environment for authoring and testing. You should expect to see connections to other systems, some way to register them and use them. You should expect, move that thing out of the way. You should expect to see workflow orchestration, of course, that's the heart of the system, and an AI reliability mechanism framework that will execute the application, the workflow application. You should expect to see connections to other systems to kick off work. So it could be a new email arrives, or a form gets filled out, or an update happens in ServiceNow that triggers a ticket ID that kicks off a workflow. There should be a way to do that. And you should see support for different AI models. OpenAI's model, Gemini's model, Claude's model. The platform should be able to handle different models and choose the best one for your application. That's what you should expect to see. Now, Thunk.ai is, in our opinion, a best-of-breed platform for no-code AI automation. When you evaluate such platforms, and there's multiple of them, you can think of qualitative measures and then quantitative measures. The qualitative measures are around authoring. What is the skill level needed? In the case of Thunk AI, you need to be a process owner. How much time would be needed? A few weeks? Is there an environment in which you can easily create applications, automations, test them, and iterate? You have to iterate many times to tune and refine them to get to the point that they will be reliable. So it's important that the iteration be efficient and fast. Then the runtime, and if you're evaluating that qualitatively, you might want to know, what are the reliability mechanisms? What are the security and compliance mechanisms? Are there deployment options that let you have private instances that isolate your data and isolate your AI use? Can it be deployed into your own cloud tenant? These are valuable and important decisions. And then, does it integrate with multiple language models? And does it have the ability to integrate with multiple applications? That's really important on the qualitative side. And then when you go to the quantitative side, you really want to understand things you can measure. What is the time to POC? What is the time to production? In the case of Thunk.ai, it's 3 months to POC and 3 months to production after that. The second one is really important. Are there demonstrated reliability benchmarks? Almost no vendor will provide a reliability benchmark because those numbers are really bad. In the case of Thunk AI, we've published, we call it a Hi-Fi AI automation reliability benchmark. The first benchmark we have published demonstrates a reliability measure of 97.3%. It's really important to get measures of these different systems that demonstrate this on some public data set and public example. And then, of course, the measured reliability results on the actual POC in your environment. This can only be observed when you're doing it, but our recommendation to a customer is do not proceed past the POC unless you get to a 95% reliability result, because you will not be happy with it once it's in production.